Okay, so here is our second last video. It's coming up quick, guys. We only got a couple more. So this is a continuation of what we were doing in video 3. We're still going to be calculating pH, pOH, hydrogen concentration, or OH concentration. I call this choose your own adventure because there are going to be some problems that are going to involve 2 steps. So 2-step problems are ones where you're not direct. So like say we're asked for the hydroxide, but you have the pH, all right? That you cannot go directly to because the pH only relates directly to the hydrogen ion, and then you have to put the hydrogen ion into OH or whatever. Or you could solve for the OH and then put it in to get the pOH or whichever way. So anyway, I don't know if I said that right, but there are 2 different paths when you have 2 formulas. So when you need 2 formulas, it's not a direct relationship here in one of these formulas. You will have 2 choices of which way to go. Now, if it were me, I would always choose this formula if I can use it because pH plus pOH equals 14 is the easiest one on here, but it does not have to be that way. We will do it both ways. So I'm going to show you a problem that is like this. So it says calculate the OH or the hydroxide concentration for a solution with a pH. So notice here, OH only goes directly to pOH. Or in this case, I pH, so it's only going to go to the H first. Then I have to go to the pOH, all right? But there's a couple ways I could do this. So I have pH, all right? So I'm going to show you this by highlighting. The pH, all right, is what I have. So this can sometimes help you if you highlight it also. The pH can be right here and right here. I get to choose which of those formulas I want to start with. Remember what I just said? I'd rather start with this one because it's the easiest. So pH plus pOH equals 14. What am I going to get from this? I'm going to get the pOH. And then you see, once I have the pOH, I have 2 choices. Well, I already got it from here. And now what? I can get that. All right. So here's how we go. pH plus pOH equals 14. So we can plug that in. The pH is 3.78 plus the pOH is 14. So just to solve this, of course, to get pOH, I'm going to take 14 minus 3.78, and that is going to give me 14 minus 3.78 is pOH equals, I know I had the equal sign there, 10.22. Now let's make sure that is the number of decimal places. Well, pH, 2 decimal places. Remember, pH and pOH, we go to decimal places. So these 2 get to be the same. So that is correct. That is not my answer, though. I only have to use this to get to that. Now, what do I want? I want the hydroxide. Again, I have 2 choices for hydroxide. I don't know why I don't have the other color right now. So hydroxide is here or here. Of course, since I already had the pOH, look how that links directly to that one, right? I could have gone the other way, and I'm going to show you that in a second. So pOH equals negative log of the hydroxide. And so what am I going to do? I'm going to plug in the pOH. So 10.22, plug it into the front here, is negative log of the concentration of hydroxide ion, When you are solving for concentration, you have to concentrate. It's not just a plug it in my calculator. It is a undo the log and the negative. So that means 10 to the x, which is negative, though. We always bring that negative first, 10.22, whatever that x is. And that will give me my hydroxide. Remember, dividing by log, or 10 to the x, is very easy to find on here because it's just the second key on the log. So you would take the log to get the pOH, but to get the concentration, you do the opposite. So second log, that'll give me 10 to the x on my calculator. I go all the way down to the bottom for my negative sign, not a subtraction sign. And then 10.22. Most people mess up because they don't put that negative in there because it had to be undone here also. Don't have to close the parentheses. So my hydroxide concentration is 6.02559. We always write more of the number than we need and then go to sig figs so I know if there's an issue somewhere where it is. So we still have 2 decimal places, right, in the pOH. So we had 2 decimal places, so that goes to 2 sig figs. So I'm just going to look at the entire number here, those 2 sig figs. So the answer is 6.0 times 10 to the negative 11th. Do not forget to put the concentration unit. Concentrate, okay? Concentrations have molarity. That we already know, and we'll circle our answer. Now, what about the other route? You mean we could do this two ways? Yep. So instead of, when we get the pH, we could start with this one, okay? The pH equals negative log of the hydroxide or hydrogen ion. So I'm going to plug in my pH just like I did before. 3.78 equals negative log of the hydrogen ion. Remember, we're going to get the hydrogen ion because H and H correlate. This is the same as we did for the pOH over here, but we're doing it for the pH. So it's 10 to the negative 3.78, so it's 10 to the x, to get this hydrogen ion concentration. What is that going to be equal to? Well, we're going to, again, divide by the log, which is undoing the log, second log, negative, because we have to move that negative, 3.78, and we get, we're going to go into scientific notation. Remember, second psi, you can go between flow and psi all you want, psi, and hit enter, because that will be a lot easier to write. Concentrations usually want to be in scientific notation, whereas pOH and pH go in decimal for flow. 1.6595 times 10 to the negative 4. Again, we're going to more sig figs than I need. How many sig figs? Well, again, we have 2 decimal places in the pH. That means 2 sig figs here. This is not my answer yet, but I know that I have a hydrogen concentration of 1.7, because that's 6 rounds, that are 5 rounds, that's 6, times 10 to the negative 4. That is a concentration. That is not my final answer because I need to use that because they want hydroxide. So what do I use now? Well, I look at my formulas. I can use this one with the hydrogen or that hydroxide to get the pOH, but that's not what I want, or pOH I don't have to get the hydroxide. Sorry, I said it the wrong way. So I have to use this one, the ionization of water. So it's always equal to that 1 times 10 to the negative 14, never limits the sig figs. And so all I got to do is plug that in. This is a hydrogen, 1.7 times 10 to the negative 4 times the hydroxide equals that 1 times 10 to the negative 14. So we're going to divide by 1.7 EE negative 4, 1.7 times 10 to the negative 4. And that will cross off here and, of course, give me my hydroxide concentration. So I just have to enter it in my calculator, right? 1 second EE, so that's the times 10, negative 14, divide 1.7 EE, so that's the times 10, no times, no 10, no caret, negative 4, and we have an answer of 5.882 times 10 to the negative 11th. Oh my goodness, we have 2 sig figs. Remember, this one doesn't limit it. It's 1.0000 forever and ever. So 2 sig figs from our answer before. So it's going to go to 2 sig figs again because we're concentrating again and again. And the 8 now rounds that. So it is 5.9 times 10 to the negative 11. Now we did this one on purpose to show you that there could be a very slight difference. So this is 6.0 and this is 5.9. It's just sig figs and how they end up rounding. I will accept both answers. So you already know this one is not correlating, right? OH, now we got NH. So those do not correlate. So you're going to have to take 2 steps to solve this problem for the WISC tonight. Have fun and ask questions in class tomorrow.